So which came first, the galaxy or the black hole? There is a theory that at the center of our galaxy is a black hole that swallows things, everything, including light. And where it all goes, no one knows. Scary stuff. What if black holes didn't swallow things? What would that look like? When we talk about the universe, that big thing out there, if equations are your only tools, then you can use all your mathematics and still overlook something. We are going to take Albert Einstein's advice. He once suggested that imagination comes before knowledge. And according to biographer Walter Isaacson, Al used his imagination often. 100 years ago, a Catholic priest used his imagination to describe a singular event, the primeval atom, the one that starts it all, jokingly referred to as the Big Bang. And so voila, here we are. We would like to offer you an alternative, one in which creation continues. It keeps creating. It's what it does, spreading in waves. We have an equation for you, one you might want to consider. Otherwise, we're going to use arithmetic. We're going to keep it simple. Ultimately, it's going to come down to a question of perspective. It's either one or the other. At the center of our galaxy is a giant black hole. We don't know what a black hole is. We don't know, what's inside. We do know that it spins really fast and that light bends as all sorts of matter is swallowed by the black hole. 100 years ago, Albert Einstein predicted gravitational waves. 100 years later, some very talented people in Louisiana and Washington State detected a gravitational wave. In 5 years' time, astronomers will have detected more than 50. A gravitational wave is the product of a collision, mostly involving black holes. When black holes collide, they generate a tsunami, so that when the leading edge of the wave passes through us, it provides for us a sound like a drop of water falling into a full bucket. Bloop. Given the limited area of search, and that short 5 years, one could reasonably consider that black holes collide frequently. And in order to have a collision, at least one of those black holes was in transit. Do they move around? And if they're anything like the big one in the middle, given its appetite, we are surrounded by invisible predators. Now, if you find yourself feeling a little distraught, it gets worse. We have, in addition, colliding galaxies. So now we have these spiral behemoths smashing into each other. The only possible outcome is absolute chaos, a mass extinction of creation. Here's creation making all this stuff, only to lose it to poor driving skills. Add to this scenario the expanding universe. As a consequence of the Big Bang, galaxies are all hurtling outward, everything moving away from everything else, and at ever-increasing speeds, so that we're getting to where we are going faster than we think. And it is not inconceivable that the time comes when we no longer see another galaxy. We've gone too far, and so have the others, and now we're alone. I don't know about you, but this is where I get off the tour bus. This does not compute. This does not at all sound like creation. This sounds like the opposite. Let me see if I get this right. At the center of our galaxy is a giant vacuum just sucking things down. We are surrounded by 1,000 miniature versions racing around playing Pac-Man. We have galaxies that crash into each other, Seriously, who is driving these things, right? And all the while racing at exponential speeds to reach a dark and solitary destiny. And that's assuming, of course, there is anything left, right? Don't forget about the glutton here in the middle, slurping it all down. The only thing more absurd than this entire scenario is the Big Bang. Here's the problem with the Big Bang. It's a one-time gig, one and done. We got one firework, and that's it? Apparently that's it. And now we disappear into the darkest of dark nights, and all seemingly for naught, all of which might suggest that the universe is a mistake. This wasn't supposed to happen. This is unauthored creation. It's a cataclysmic mess. How else do you explain the need for a giant vacuum cleaner? We are going to take the world's most famous and revered equation and flip it so that we get E. 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 C squared. E. C squared equals ejecti. It's not going down a hole. It's coming out of a hole. And it spins so fast. What a surprise when we found out that the thousands of stars above us and the thousands of stars below us and their 250 billion cousins are all going around that black hole in the same direction. Now, before you dismiss this too quickly, we have an authority on this very subject. Genesis, verse 2. Yahweh describes it as a deep darkness. It's deep and it's dark. A deep darkness that generates, and I quote, a divine wind. A divine wind. Followed immediately by, and I quote, and then there was light. Yahweh was not describing destruction. He was describing creation. And now that we have you open to this other possibility, there's something more. We've been watching these stars for millennia. There's quite a variety. We have red giants and blue giants. Orion has one of each. We're completely surrounded by cute little white dwarfs. We have invisible stars called brown dwarfs. And then we have stars like ours. Now, as it turns out, we are not the only solar system. And at last count, there's a bunch. And they keep finding more. Early observations suggest that stars have a knack for collecting planets. Planets all of which swerve around that star. Much like we swerve around our star. And much like these billions of stars swerve around that black hole. What we don't have are collisions. Stars do not bump into stars. Planets do not bump into planets. And for good reason. Collisions are bad for business. The entire galaxy's business. Imagine the impact of 1,000,000 ricochets. Creation is making things, not blowing things apart. Stars provide order. Stars and planets do not collide. But that is not what black holes are doing. What's up with the black holes? Apparently, they do collide, and often. They somehow manage to find each other. Now, this is not big fish, little fish. This isn't the big black hole extracting the other's essence and ejecting the remains out the back door. This is energy absorbing energy. They are merging. Let's do some arithmetic. 1 + 1 equals 1. When black holes merge, we have lost a black hole. We had 2, now we have 1. Are we running out of black holes? Let's do some more arithmetic. Imagine one of those black holes was a 7 and the other an 8. This is energy merging with energy. So now we have a 15. Now that just means our new and improved black hole spins at 15 times the speed of light, which is incredibly fast. We would love to travel at that speed, but 15 times the speed of light is not c squared. It's not even ballpark. Our little 15 is going to need to beef up, and given the opportunity, that's exactly what it's going to do. Black holes merge because that's what they do, at which moment you should be asking yourselves the only question that actually matters. Why? Why is creation doing this? Creation is making things. How do merging black holes make things? Well, brothers and sisters, it's just a matter of time. When black holes merge, they get bigger and stronger. And then they merge again and again and again and again until finally we have two massive black holes, each spinning at 100,000 times the speed of light, which is still not c squared. But as they go into their dance and they finally merge, we hear a bloop, and we now have a black hole that spins at c squared. And when a black hole spins at the speed of light squared, it starts to look like this. These are called dwarf galaxies. Toddler is more accurate. These dwarf galaxies as a group, in totality, completely outnumber all of the other types of galaxies combined. And the vast majority of these dwarf galaxies can all be found in close proximity to big ones. This is our sister galaxy, Andromeda. Anne has been a busy girl. She has 14 of these dwarf galaxies, and we're thinking there might be a couple more on the other side. Near the top, you can find one of those dwarf galaxies, one that's starting to look a little different. This one is just beginning to extend its first arm. Not only does that black hole generate all of this creation we call a galaxy, it makes copies of itself, a dozen or so, all of which in turn are going to someday provide the same services. This is creation on steroids. This is creation attempting to completely overwhelm emptiness. Beyond the shores of our universe, there is nothing. There's nothing there. But that apparently is going to change. Now, you haven't lost anything. You still have your equations and mathematics that prove that that black hole is just sucking things down because it makes so much sense. Oh, yeah. Or you might want to consider that, yes, it's a hole. There are only two possibilities. Stuff is either going down that hole, or what we have here is a dynamo that spins at an impossible speed, generating electromagnetism, which at 1,000,000 degrees launches plasma into an ocean without a shore, filled with ubiquitous dark matter at minus 459 degrees. What could possibly happen? Which version do you think it is? Which version makes more sense? Which version screams creation? A black hole that swallows creation is utterly frightening. A black hole that electrifies creation is utterly fantastic. And if you cannot say utterly fantastic, then we're not talking about the same universe. Now imagine for the moment that galaxies do not collide. And here's why. That star we call a sun, the experts are going to tell you that the sun has an electromagnetic field. The sun does not have an electromagnetic field. The sun is an electromagnetic field. Think of the sun as an electrified magnet. They're magnets. And we know that if magnets don't want to come together, they won't. Stars do a wonderful job of collecting planets, and an even better job of keeping other stars at a distance. which goes a long ways to explaining how 250 billion stars manage to avoid collisions. So what do you suppose the odds are that a galaxy of 250 billion electrified magnets is going to smash into another galaxy filled with billions of electrified magnets? Oh, I'm certain they come close enough to alter each other's shape. Tell me one steals stars from the other. Makes perfect sense. What they're not going to do is devolve into a convulsive annihilation of creation. Creation is making stuff, not blowing it apart. If your equations say otherwise, then maybe you need some new equations. You can start with merging black holes. That should keep you busy. If you get anything from this talk, the universe is not ending. It is expanding exponentially and quite possibly just beginning. Beyond the shores of our universe, there is nothing, but that is about to change. We will now conclude our talk with a question. Infrared astronomy has already given us a couple surprises. I will be surprised if the Webb telescope does not provide us with a surprise. For instance, what is the matter with dark matter? When we say dark matter, what are we saying? Does it have shape? Is it mobile like everything else? Maybe with improved infrared, dark matter might not be quite so dark. This is the 21st century. What might we see? Brothers and sisters, it's a whole. Your choice. Se acabó.